Hey math guys, one more math video for you coming on for the end of the week here. This is Thursday's math video. I'm going to continue on with page 370 here, and we had just finished up the last video, got cut off a little bit again, I ran out of time. But we're looking at these common denominators and using equivalent fractions to create common denominators, which like I said in the last video, very important to be able to do moving forward so we can build up our skills and be able to actually add and subtract. So we've done estimating so far this week with benchmarks, 0, half, and 1. Now we're working on how we can practice the skills of creating common denominators by making equivalent fractions. So like we saw in this one we left off on, 1/6 is the same as 3/18, and 1/9 is the same as 2/18. And how that can be useful is what we'll notice here is we've got common denominators here of 18. So if we were to add 1/6 and 1/9, we can't do that until we have a common denominator. So what we're doing now again is sort of working our way toward being able to add fractions that don't have the same denominator by making equivalent fractions that do, and then adding on from there. Okay. So I'm going to go ahead and continue on with these three we see at the bottom of page 370, and then we'll look at a couple on the next page, which was your assignment from yesterday, just to review a few, and then we'll also preview the homework page, which is the other thing you're going to submit, and then you're going to be done for the week. I know I'm throwing a lot at you this week. Again, it's a chance for us to try to catch up and speed along a little bit and try to get to a good point before the end of the year. Not the preferred way to do it. I'd honestly much rather be back in the classroom right now working with you guys on this. But I do thank you for watching these videos and working hard on the stuff where you're at, okay? So let's go ahead and look at this. When we talked about common denominators, these are a few good things to point out. I'm going to kind of use three different strategies, and one is actually one that makes it pretty simple. One strategy we looked at, we're going to use for number 2, is if we just multiply both denominators, that's going to come up with a common denominator. So in this case, if I have 3 and 5, and actually that would be the lowest or least common denominator, if I multiply those two together, I get 15, okay? So let's talk about if I want my denominator for each fraction to be 15, let's talk about how we can do that, okay, how we can get to there. If I have 1/3, let's just kind of set up, we have 1/3. We know we want it to make 15ths. And I also have 1/5 that I know I want it to be 15, so I'll change to a different color. So if I do 1/5, now I want that to be 15, so we can kind of set up like this. Then what we were working on is just like in those circle examples we had from yesterday's video. If I go back to those real quick, we saw the visual of how we can split these up into the same amounts. Again, these are all equal to 1/2. It's the same amount of shaded in green stuff here. But we also looked at how we can multiply. If I go from 2 to 8, I multiply by 4. And I go from 1 to 4, I multiply by 4. So if I do the same thing to the numerator and denominator, multiply by the same amount, it's going to give me an equivalent fraction, okay? So then we just have to figure out what is that amount we're multiplying, okay? So let's talk about that. If we have 15ths, if we're going from thirds to 15ths, if I go from 3 to 15, think, what do I multiply that by? 3 times what makes 15? That answer would be 5. So 3 times 5 makes 15. If I do the same thing to the numerator, that's going to give me an equal amount, an equivalent fraction with a different denominator that would, again, down the road, allow me to add these two amounts together. 1/3 thirds times 15 times 5, it gets me to 15. So I have to go 1 times 5 to get to 15. Of course, 1 times 5 is 5. So 5/15 would be an equivalent fraction that's going to have a common denominator like here on my blue fraction here. Now in the other one, I'm going from 5 to 15. So how do I get there? What do I multiply by? 5 times 3 makes 15. So then I have to do the same thing to my numerator to make it equivalent. 1 times 3 would give me the numerator, and that of course would be 3, okay? So what I can do here is I can rewrite 1/3 and 1/5 as fractions with 15 as a common denominator, and then I get these. So these are my answers here, 5/15 and 3/15, okay? If we go on to number 3, we can see a case where we have 2/3 and 5/9. Now, sometimes we can have a common denominator that already has one of the denominators we see. So if I look at these two denominators here, 3 and 9, I can get from one to the other without changing one of them. So if what I'm saying there by that, I can get from 3 to 9 by multiplying by 3, and then I can use my 9 as a common denominator. So really, 5/9 is already one of the fractions that we can use. The common denominator we can use is 9, okay? So sometimes we'll get lucky like that. We won't have to change how much one of the denominators is. In this case, I can already get to 9. 9 is a multiple of 3, so I can actually keep my 5/9 the way it is, and then, hey, I just saved myself a little bit of work. I can go 2/3, turn that into a number of ninths. Then I've already got 5/9, okay? So if I, again, using the equivalent fraction strategy, if I multiply 3 times something to get 9 and do the same thing up top, 3 times how much would make 9? 3 times 3 would make 9, right? 3 times 3 makes 9, so then I have to do the same thing, multiply by the same amount for the numerator. 2 times 3 would be 6, so here's my equivalent fraction. 6/9 is equivalent to 2/3, but now it's got a common denominator with this other 5/9 that we already did. So we have 6/9, and we already have 5/9, so again, in this case, we don't have to change anything. Now we could multiply both denominators together and get 3 times 9 would be 27, which would be another common denominator. But here in this case, it's a lot more convenient, and it's our least common denominator. If we just do that, we can make one denominator become the same as the other, and that way we didn't even have to do anything for the 5/9. It can be the same, okay? The last one I'm going to use, the last strategy for this one, is I'm going to use that making a list strategy in this case. So here for number 4, we have 2/9 and 1/15. So again, sometimes ones like this, it might be a little hard to just think off the top of your head what's a common multiple or a common denominator that we can use. But if we go ahead and just list them out, let's try that. Okay, so if I do my 9s, if I go by 9s, I would think 9, I can start with that. And then 9 times 2 would be 18. 9 times 3 would be 27. 9 times 4 would be 36. 9 times 5 would be 45. So again, just listing multiples, going by 9s. I know that's not always the simplest way to count, but it's one thing we can do. Then we can go 54, 63, 72, things like that. Okay, so we can go as far as we need to. Let's say we're going to do 15 next. I'll switch to purple. 15s, if I'm going by 15s, I would start with 15. 15 times 2 would be 30. 15 times 3 would be 45. Times 4 would be 60. So again, just counting by 15s, then 75. So let's take a look at the list we've got here. What do we see? Now we've got the multiples. Now we can find the least common multiple, the lowest number they have in common, and we can use that as the common denominator. Now in this case, it's not, we wouldn't necessarily say it's a small number, but we have the number 45 we see appear in both lists. So that tells us we can get to not 45 going by 9s, we can get to 45 going by 15s, and that's what we want to use as our common denominator. Okay, so let's go ahead and do that little strategy again. So we want to get to 45 going by 9ths and going by 15ths. So let's talk about that. We have 2/9. I'm going to start off with the one I have, the beginning fractions. Actually, no, I'm going to say this is 45. We're going to use 45 for our common denominator. 2/9 would equal how many 45ths? We'll find out. So again, how do we get from 9 to 45 is where we just got to think of those multiplication facts. Everything we've done this year has been kind of building on the basic facts we know. How do we get there? So from 9 to 45, we would multiply by 5. Then I need to do the same thing for my numerator, multiply by the same amount to make it an equivalent fraction. Again, just like those circle examples we did. 2 times 5. Again, I did 9 times 5 to get to 45. So I have to go 2 times 5 to make the equivalent numerator. 2 times 5, of course, is 10. So 10/45 is one equivalent fraction we can use. Let's go to another one. So we have 1/15 is our other fraction we're looking at. And again, we want to make this 45 for the denominator because then we have common denominators. They have that number in common between the fractions. So it'll be the same amounts, just with different denominators for each fraction so that they have that denominator in common. All right, so then again, how do we get from 15 to 45? 15 times 3 would give us 45. So we got to do the same thing for our numerator, same process. Multiply by the same top and bottom, it gives us an equivalent fraction. 15 times 3 makes 45, so then 1 times 3 makes our numerator we want. And of course, 1 times 3 is 3. So here's our two fractions that are equivalent to the ones we started with. 2/9 is the same as 10/45. 1/15 is the same as 3/45. But again, now this is helpful because now we've got these nice common denominators. So if I was to add these together, I can add 10/45 and 3/45. I can't do 2/9 plus 1/15. I have to change them to that, which again, we'll get to that a little bit down the road. Okay, so there's how we can do that. That's 2, 3, and 4 on there. Now let's go ahead and real quick and look at page 371. Here we see 9ths and 15ths. Here we see, this one looks a little tricky. But I'll tell you this right now. If we want our equivalent fractions for 6 and 21, or sorry, our common denominators we can use is going to be 42 for a common denominator. Okay, so if you're still looking at, if you were a little tripped up by this one, I'm just going to real quick show you. We want to have 42. I guess we call those 40 seconds. 42 for each. If we just do it real quick, let's think, okay, if I go from 6 to 42, I would do times 7. So 1/6 times 7 makes 42. So 1 times 7 would make 7. Then we do the same thing for that one. If I get from 21 to 42, we just multiply it by 2. So then we have to do the same thing for this numerator. 4 times 2 would be 8. And I'm really bad at making the 8s on this thing. Not too bad. So 7/40 seconds and 8/40 seconds. Sometimes we'll see fractions we wouldn't normally use, and we won't use this too often, but those are the kinds we can do if we need to. So again, they're not ones we would say normally, but we can work with them. Number 8, the common denominator in this case should be 36. I'm just going to jump through a couple. 36 here. And let's see how we get there. If I go from 12 to 36, I would multiply that by 3. So I have to do the same thing for my numerator. 7 times 3 here would make 21/36. And then the same thing for the other one. 5/18 to get from 18 to 36, I'd multiply by 2. And then 5 times 2 to make the equivalent fraction would be 10/36. Okay, so there's just a couple examples of some of the ones. I think you only have to go up to number 11 here, so I'm not going to worry about the word problems because I know we're going through them pretty quick. Okay, so I really just want to make sure we get into those basics. All right, so what you got for today is the homework page. And again, since I know I'm throwing a whole lot at you here, we're trying to steamroll through a few of these. Let's talk about some of these common denominators. I'm going to do this for you. I'm going to give you a couple of common denominators, and we might look at 1 or 2 of the equivalent fractions. But what we'll do here is just talk about what is our common denominator for each part here. And then we'll talk about making those fractions that are equivalent, okay? 3 and 4, again, these are the ones we can multiply together. We would say 12 would be our common denominator, okay? Now for the equivalent fraction, they should both be 12 for the denominator, so it's up to you guys to talk about what's going to be the 2 equivalent fractions. Again, talk about how if I go from 4 to 12, how would I multiply? If I go from 3 to 12, how do I multiply? And do the same for each numerator, okay? Notice with this one, number 3, we could multiply those together and do 18. But what we can also do is if I go from 3 times 2, it gives me 6. I can actually use 6 as a common denominator, and that allows me to, since I already have a common denominator, I'm going to use 6. I can say 5/6 is one of my fractions. I don't have to do anything. Then you just have to think, if I go from 1/3, how many 6ths would that be? That's a pretty easy one to figure out too. Again, just think about if I go from 3 to 6, how much do I multiply by? And then I do the same for the numerator, okay? Same thing for number 5. We can go from 2 to 8. We can actually use 8 as a common denominator. Again, I'm just giving you a few little hints along the way here. 5 times 3 is one we did where we multiply those together to get 15. So again, just a few examples here, okay? All you need to do for the homework is up to number 11. Don't worry about number 12 here, and then don't worry about the back page. Again, just trying to get us through to get to the basics here and get ready to move on, okay? So we got a couple word problems, but again, it's the same idea, just find those equivalent fractions, okay? So I hope you guys do a good job on that. Again, look for the link to turn these in. Look back to here. We did a couple setup things, so I'm getting you off on a good start, and I'll look forward to seeing these turned in from you soon, okay? Thanks for hanging out with me this week in math. I know it's been a quick few days here getting through things, but thanks for watching the videos. Hopefully these are helpful. And again, getting into some new stuff with fractions, and next week we'll start adding and subtracting these guys. But again, finding these common denominators by using equivalent fractions is a big step in that process. So make sure you do well with that, okay? All right, guys, have a great weekend, and I'll talk to you soon. Have a great day.